Welcome to This Explainer, where we're diving deep into how the automotive world is completely shifting from traditional mechanical engineering into a high-stakes artificial intelligence battleground. For a century, cars were judged by their horsepower, their suspension, maybe their leather stitching. But today, that entire paradigm is basically being flipped on its head. Here is our roadmap for today. We'll be looking at Tesla's hybrid vertical integration, pure vision versus sensor fusion, the shadow mode data moat, the fall of LiDAR, how competitors are adapting, and finally, the dawn of physical AI. Okay, let's start with a really crucial concept, the software-defined vehicle, or SDV. In an SDV, the real premium feature is the AI brain that operates the standardized body. Think about it. Electric motors and batteries, they're rapidly becoming commoditized. The true differentiator now isn't the physical chassis at all. It's the intelligence of the invisible chauffeur sitting behind the wheel. Let's kick things off with Section 1, Tesla's hybrid vertical integration. Tesla structures their components completely differently from legacy automakers, who historically just bought black box solutions. Tesla strictly controls the autonomous brain and operating system 100% in-house, but they smartly outsource the standard manufacturing and infotainment chips. For instance, they design their own full self-driving or FSD chips, but they let Samsung or TSMC actually manufacture them. They use standard AMD Ryzen chips for your touchscreen games and Sony sensors for the cameras. So it's a highly calculated hybrid model. Own the brain, outsource the commodity. Moving right along to Section 2, pure vision versus sensor fusion. Now we have to talk about the controversial catalyst that totally changed the trajectory of self-driving technology. The core philosophy here boils down to first principles thinking. As Elon Musk pointed out, humans drive with 2 eyes and a brain. So why mix 4 different sensors? This led to the radical decision to strip out radar and LiDAR completely, relying solely on visual photon data. I mean, if our biological visual system is enough to navigate complex highways at 100 kilometers per hour, why should a car need a spinning laser on its roof, right? When you compare the two approaches, legacy systems actually get confused when their sensors disagree. Let's say a radar signal bounces off a bridge and says, obstacle, but the camera says, clear road. What happens? You get terrifying phantom braking. Legacy automakers tried to fix this with millions of lines of manual C++ code. Tesla's pure vision, on the other hand, relies entirely on an end-to-end neural network that's trained to understand context, which completely bypasses those conflicting signals. So with FSD version 12, Tesla literally deleted hundreds of thousands of lines of manual code, creating an end-to-end system that turns raw video directly into driving actions. It is no longer a human engineer typing, if a pedestrian steps out, press the brake. Instead, it's a single massive neural network that watches millions of hours of good human driving and implicitly learns how to steer and brake on its own. It's a real game changer. Which brings us to Section 3, the shadow moat data moat. So how exactly did they train this massive neural network to drive so naturally? Because an AI is only as smart as the data it consumes. Well, the secret is 6 million Tesla vehicles driving on roads worldwide, constantly running in shadow mode to evaluate human drivers in the background. Even when a driver isn't using any autonomous features, the car's computer is silently watching. It calculates what it would have done and compares that to what the human actually did. To put that scale into perspective, this global fleet has gathered an astonishing 3 billion kilometers of rare, real-world video clips, creating a completely insurmountable data moat. When a human suddenly swerves to avoid, say, a weirdly shaped pothole, that edge case video is captured, compressed, and sent right back to headquarters. Competitors who are just testing a few hundred robotaxis in perfectly mapped cities simply cannot mathematically replicate this level of scale. Now, crucially, the car's edge computer handles all of the driving autonomously with 0 latency, while the massive cloud supercomputers handle all the heavy lifting of training the AI. Think about when you're driving into a tunnel with absolutely 0 internet connection. Your car cannot hesitate, so the onboard chip handles 100% of the live driving. Those giant supercomputers back in Texas and New York, they just review the homework and send down smarter updates later. Next up is Section 4, the fall of LiDAR. So what actually happened to that billion-dollar industry that insisted you absolutely couldn't drive without laser sensors? Well, it led to a devastating LiDAR winner. Once celebrated startups completely collapsed because their expensive sensors just couldn't compete with cheap cameras powered by brilliant software. Once massive unicorns were forced to merge just to survive, some filed for bankruptcy and others saw their stocks decimated. You just can't justify slapping a $1,000 sensor on a mass-market car when a $50 camera and great AI can do the job better. The fundamental flaw here is that while LiDAR flawlessly measures physical distance, it lacks the intelligent context to understand what it's actually looking at. If a sensor spots a floating object, LiDAR just sees a solid obstruction. It takes vision AI to realize, oh, actually, that's just an empty plastic bag blowing in the wind. It's safe to keep driving. Let's look at Section 5, how competitors are adapting. Realizing they were losing the software war, legacy automakers kind of panicked and formed massive alliances to catch up. They knew there was no way they could build this tech overnight from scratch. This new world order requires legacy brands to partner with tech giants just to get the AI brains they desperately need. Notice how Mercedes and Hyundai align with NVIDIA, while BMW relies on Qualcomm, and Volkswagen taps Mobileye. Since they don't have the in-house capabilities to design custom AI chips and neural nets, they basically have to buy their intelligence off the shelf. Even Chinese manufacturing giants like BYD are scrambling to source advanced AI chips through really complex geopolitical workarounds to power their vehicles. I mean, they practically build the entire physical car themselves. But when it comes to the brain, they are balancing high-end NVIDIA chips where legally permitted, while aggressively finding local chip makers like Horizon Robotics as a backup plan. The terrifying reality for these legacy automakers? The mechanical components they spent literally a century perfecting have become mere commodities. 100 years ago, you bought a car for the engine. Today, batteries and motors are essentially equalizing across the board. The value of your car is entirely dictated by the software that controls it. Finally, we reach Section 6, the dawn of physical AI. Let's zoom out for a second, because driving is really just the prologue to a much bigger technological story. We aren't just talking about cars anymore. Unlike chatbots that generate text with no real-world consequences, driving AI represents the highest possible difficulty level of interacting with the physical world in real time. If a text AI takes 3 seconds to load a poem, nobody cares, right? But if a driving AI takes 3 seconds to process a pedestrian stepping into the road at 100 kilometers per hour, that is a catastrophic disaster. So think about this. If you can solve the absolute chaos of high-speed driving, slower tasks like factory work or household chores, they become trivially easy. The physics of understanding 3D space, predicting movement, and controlling a machine based on visual inputs is exactly the same, whether it's a car dodging heavy traffic or a machine folding your laundry. This marks the dawn of physical AI, and it perfectly explains why Tesla literally took their autonomous driving brain and put it directly into humanoid robots. It is the exact same end-to-end neural network architecture. You put cameras on the head, route the video into the exact same FSD chip, and instead of telling wheels to turn, you're telling robotic fingers to pinch. It's wild. So this leaves us with a pretty profound thought to ponder about our future. The race for the software-defined vehicle was actually never just about replacing the driver. It was always about building the first true artificial intelligence that can see, understand, and interact with the physical world. Thank you for listening. It was presented by HK Automotive.